George Lucas showed us a binary sunset on Luke Skywalker's home planet of Tatooine. But could a planet actually form in the habitable zone of a system with two stars rapidly orbiting each other? Statistically, the majority of stars are in multiple star systems. Despite the fact that any given system is more likely to be a singular star, multiple star systems still make up a large percentage of systems in our universe. Could these binary and multiple star systems have a stable habitable zone, or even support life? Because these systems involve two or more stars, the set of conditions that could result in a stable habitable zone is less probable. There are many situations in which a stable habitable zone could not exist. Systems containing high-mass stars are usually not good candidates, even in single-star systems, due to their short lifespan. If the stars are too far apart, the planet's orbit may be unstable or irregular, leading to drastic temperature shifts that would exclude the possibility of life forming. The best scenario for a planet remaining in a stable orbit in the habitable zone would be for two low-mass stars to be very close together, and the planet would have to be somewhat close to them. It's hypothesized that the ideal scenario would be two stars that each had approximately 80% of the mass of the Sun. This would give rise to other challenges to life, however. Radiation from the stars could potentially be a problem for planets with weak magnetic fields or thin atmospheres. And the planet would be more likely to be tidally locked, meaning one face continually faces towards the stars, as in the case of the Moon with respect to the Earth. These small stars are among the most common types of stars out there, and have very long lifetimes, which increases the probability both of their encountering one another and forming binary systems and allowing time for life to develop on a planet in their habitable zone. It's thought that binary star systems can actually help the rate of planet formation by increasing the accretion of the protoplanetary disk. It seems unlikely that planets would form in systems with three or more stars, as the gravitational effects of these stars, which are in unstable orbits themselves, would interfere with planetary orbits to a severe degree, possibly even throwing them out of the system entirely. Recent advances have also led to some planets being identified around binary systems. The Kepler Space Telescope has recently discovered the Kepler 47 system, which consists of two planets, Kepler 47b and Kepler 47c. Kepler 47c is a gas giant that is located in the habitable zone of its parent system, which means liquid water could exist. Though it's a gas giant slightly larger than Neptune, the fact that it is there and in a stable orbit is not an insignificant discovery. We are likely limited only by our ability to observe extrasolar planets, with small terrestrial planets being more difficult to discern than gas giants. The fact that planets are there, though, indicates that other, more hospitable planets could be as well. Kepler 47c itself could even have a life-supporting moon. The Kepler 47 system is not even ideal. It consists of a main sequence yellow dwarf slightly smaller than the Sun and a small red dwarf. To date, about 70 extrasolar planets have been observed orbiting binary star systems. As our methods of detecting extrasolar planets advance, we'll hopefully be able to view more terrestrial planets that we know can lie in the habitable zone. We've even found a terrestrial planet orbiting a binary system in our closest neighbor system, Alpha Centauri. Though this planet is far too close to its parents and its surface is likely molten, it still indicates that terrestrial planet formation is both possible and common in multiple star systems. In systems with stable habitable zones, life could even arise. Who knows? Maybe the first aliens to contact us are watching a binary sunset.